This lesson, we're going to learn how to determine an equation of a polynomial function. Polynomial functions can be written in two different formats. One is called the standard form, the other one is called the factor form. Given a list of the zeros, or by looking at the graph, we can find the zeros. A family of the polynomial function can be found. And once we substitute a point that is on the graph, then a particular member of that specific polynomial family can be determined. Now, let's do some examples to see how we can determine an equation of a polynomial function by looking at the graph. Example 1. First, let's identify our roots with the order. So the first root will be at -2. Because at -2, it looks like a cubic function, so we say order is 3. The next root will be at x equals to 3, and the order will be 2 because it looks like a parabola. Then we can generate the family equation, fx equals to a times by, when x equals to -2 means x plus 2 is the factor. Since the order is 3, that means the exponent is 3. Next, when the root x equals to 3 is generated from the factor x minus 3, and the order is 2, that means the exponent is 2. Now, we have a family equation in factor form. However, we want to find a particular family that satisfies this graph. So we have to find a clear point that is on the graph. So we can see this point is very clear on the graph. So we say the point is at -1 and 20. And that's substitute 20 into y, -1 into the x, into the family equation to find a. So we get 20 equals to 16a, divided by 16 on both sides, reduce the fraction, we get a equals to 5/4. Now we can say the particular equation in factor form will be fx equals to 5/4 times by x plus 2 to the power 3 times by x minus 3 to the power 2. Example 2. Let's find the equation again. Step 1, let's find all the roots. The roots will be at -4, -1, and 3. Then we look at the order of the roots. When the function goes through those roots, they all look like a straight line. A straight line here, straight line there, straight line there. That means all the roots are having an order of 1. Now we can find our family equation in factor form. Fx equals to a. X equals to -4 was coming from the factor x plus 4. Order of 1, that means the exponent is 1, so we don't have to write it. X-intercept of -1 was coming from the factor x plus 1. Order 1, exponent is 1, so we don't have to write it. X-intercept at 3 was coming from the factor x minus 3. Once again, the order is 1, that means we don't have to write the exponent of 1. Then, let's find a clear point that is on the graph in order to help us to find the value of a, to find a particular equation. As you can see from this graph, the y-intercept is very clear. So let's use the y-intercept. The coordinate of the y-intercept is at 0, 12. So we substitute 12 into the y, 0 into the x to find a. Then we will get a equals to -1. Therefore, our particular equation will be fx equals to negative x plus 4 times by x plus 1 times by x minus 3. Example 3. First, let's find the roots. The roots will be at -2, order 1, -1, order 1, 2, order 1, and 3, order 1. Then we can find our family equation in factor form to be fx equals to a times by x plus 2 times by x plus 1 times by x minus 2 times by x minus 3. Let's find a clear point on the graph, which is the y-intercept at 0 and -12. Substitute 0 into the x, -12 into the y, we will get a equals to -1. Therefore, our factor form for the particular equation will be negative x plus 2 times by x plus 1 times by x minus 2 times by x minus 3. Example number 4. Once again, the first thing we have to find is the roots with the order. So let's look at the roots. The first one's at -1, order is 1. Next one, the root is at 1, and order is also 1. The last one, the root is at 3, and this time it looks like a parabola, so we say the order is 2. Then we can find the family equation in factor form. Fx equals to a times by x plus 1 to the exponent 1 times by x minus 1 to the exponent 1 times by x minus 3 to the exponent 2. Then, let's use the y-intercept to find the value of a. The y-intercept will be at 0 and -9. Substitute into the family equation, then we get a equals to 1. Therefore, our particular equation in factor form will be fx equals x plus 1 times by x minus 1 times by x minus 3 squared. If the question wants us to find the particular equation in standard form, then all we have to do is to expand the factor form to get the expanded form, which is the standard form.